Let's look at the compound angle formulae. We'll start with cos x minus y is cos x times cos y plus sin x times sin y. Cos x plus y, cos x times cos y minus sin x times sin y. And sin x minus y, sin x times cos y minus cos x times sin y. Sin x plus y is sin x times cos y plus cos x times sin y. Just over time you just get used to using them. It's handy to have them recorded somewhere on a formula sheet and so on, but I mean, after a while of use you'll commit them to memory. Alright, in the case of tan, we have tan x minus y is tan x minus tan y, 1 plus tan x tan y. Tan of x plus y is tan x plus tan y, and 1 minus tan x tan y. Useful relations to be used. We can use them particularly in relation to the exact values. If I can just remind you of our triangles with the exact values. So if we just take right angle triangle like this, okay, we have 45 degrees here, 45 degrees here, this length here, root 2, this length 1 and 1, and the other exact ratio was the slightly taller triangle. That one was there, and we had with this one side length of 2, this one was 1, that was a square root of 3. This larger angle on the bottom here, 60 degrees, and the smaller one, 30 degrees. Okay, so we can use those. That last 30 degrees, I'll just, okay, and we'll just, alright, now let me write that again. 30 degrees, there we go. Alright, so if we have a look, for instance, over here, first example, we've got cos 15 degrees. We could get out a calculator, software package, what have you, but we could also just use the exact ratios too, because we could write that as, and use the compound angle formula, we can write that as cos of 60 degrees minus 45 degrees, and then from the compound angle formula, which was right up the top there, the very first one, x minus y, cos of x minus y was cos x times cos y, plus sin x times sin y. Well, if we have a look here, we have then cos of 60 degrees times cos of 45 degrees, plus sine of 60 degrees times sine of 45. Well, cos of 60 degrees is adjacent over hypotenuse, so it's 1 over 2. Alright, so we should have, if I just do that here, we have 1 over 2. Cos of 45 degrees, again, is 1 over root 2. Cos 60 is 1 over 2. I hope I said 1 over 2. Sine 60 degrees is square root of 3 over 2. Sine's root 3 over 2. Sine 45 is 1 over root 2. Okay, well, let's take that a little further, simplify that down. Okay, 1 over 2 root 2 plus 3 over 2 root 2. Rationalize the denominator, and by multiplying by square root 2 on square root 2, just means multiplying by 1, so we're not really changing anything. When we do that, we can then rationalize the denominator, and what we end up with is square root 2 plus 2 times square root 2 root times root 3 over 4. Okay, let's have a look at another example. We want to pick sine 3 pi on 4. We can write that as sine pi on 2 plus sine plus pi on 4. So if we look up the top here, what we had was sine x plus y. That's the one we wanted, wasn't it? Yep, x plus y. So it's the bottom one here. Sine x plus y is sine x times cos y plus cos x times sine y. So let's come down here. Okay, and again we have sine pi on 2. Sine of 90, we know that to be 1. Cos pi on 4, we know that to be 1 on root 2. That's 45 degrees, pi on 4 from our exact ratios above. Cos of pi on 2 is 0, so that bit's going to drop out altogether. Sine pi on 4 being 1 on root 2. That drops out and we're left with 1 over root 2. And that's it.